Welcome back to the channel. In this episode, we're going to answer the question, what is a block in blockchain? We will talk about what a block is and why they are important for the proper functioning of a blockchain network. Before we start, remember to give us a thumbs up if you haven't already. Let's get started. First off, let's do a quick recap of the term blockchain. In simple terms, a blockchain is a digital or virtual ledger that records information in a series of blocks. These blocks are then linked together in a chronological order, hence the name blockchain. Now that we've established that, let's move on to our main topic. What is a block? To put it simply, a block is a digital record that contains specific data, a unique identifier, and a link to the previous block in the chain. But let's break this down further. First, each block contains data. This is the actual information that is being stored. In a blockchain network, the data can take many forms, such as financial transactions, smart contracts, or any other type of record. Second, each block has a unique identifier. This is generated using a cryptographic hash function and is based on the contents of the block. The hash ensures that the data in the block has not been tampered with and remains accurate. Third, a block contains the hash of the previous block in the chain. This creates a chronological link between blocks, forming an unbreakable chain. By storing the hash of the previous block, each block is linked together in a sequence, forming a chain. If any block in the chain is altered, the hashes of all subsequent blocks would also need to be changed, which is practically impossible. Now that you know what a block contains, let's discuss how blocks are created. In a blockchain network, new blocks are added to the chain by a process called mining. For proof-of-work blockchains, miners verify and group together transactions into blocks. Once a block is filled with transactions, it is added to the existing blockchain. However, for proof-of-stake systems, the process is slightly different. Instead of mining, validators are responsible for creating new blocks. They do this by staking coins, which involves holding and committing a certain amount of cryptocurrency to validate transactions and add new blocks to the blockchain. Consensus mechanisms such as proof-of-work and proof-of-stake play a crucial role in ensuring the security of blocks. Proof-of-work requires miners to use computational power to solve complex puzzles, while proof-of-stake uses random number generation and the validator's stake to validate blocks. These mechanisms help to prevent malicious actors from tampering with blocks and ensure the integrity of the blockchain. Next, let's explain why blocks are important in a blockchain network. First, blocks provide security and integrity to the blockchain. By hashing the data and linking blocks together, any attempt to alter a block would require changing all subsequent blocks, which is practically impossible. Additionally, decentralization makes it even more difficult to tamper with blocks as they are distributed across multiple nodes in the network. Second, blocks ensure transparency and trust in the system. Anyone can verify the contents of a block, and the entire blockchain is publicly viewable. This allows for greater trust and accountability among users. For example, in Bitcoin, every transaction is recorded in a block, allowing anyone to view the transaction history. Third, blocks are immutable once added to the blockchain. This means that they cannot be altered or removed, providing a reliable and tamper-proof record of transactions. Now that you understand why blocks are important, let's explore some real-life applications of blockchain blocks. In cryptocurrency, blocks are used to store and verify transactions of Bitcoin and Ethereum. In supply chain management, companies like Walmart use blockchain to track the movement of products from manufacturers to consumers, ensuring authenticity and reducing fraud. In healthcare, blockchain can secure patient data while maintaining privacy and interoperability. In voting systems, blockchain can provide an immutable record of votes, enhancing transparency and trust in elections. Despite the numerous benefits of blockchain blocks, there are also some challenges associated with them. Scalability issues arise when processing a large number of blocks, leading to potential slowdowns in the network. Energy consumption is another concern, particularly for proof-of-work blockchains, which require significant computational power, consuming substantial energy. Lastly, adoption barriers exist as many industries are still in the early stages of integrating blockchain technology. Now let's wrap up our discussion. Blocks are the fundamental building blocks of a blockchain, providing a secure, transparent, and tamper-proof method of recording information. Their importance in ensuring the integrity and reliability of blockchain networks cannot be overstated. As blockchain continues to evolve and mature, we can expect to see even more innovative applications of this technology across various industries. Thank you for watching our video on what a block is in blockchain. We hope you found it informative and helpful. If you have any questions or comments, please feel free to leave them below. We'd love to hear from you. And don't forget to give us a thumbs up if you enjoyed the video and subscribe to our channel for more content like this. Thanks for watching, and we'll see you in the next video.